based on the example, you do the exercise 4.2.
Repeat example 4.2, but assume the first horse pulls at a 40-degree angle, the second horse at negative 20 degree. Answer 0.52. Oh,
Okay. So now they actually ask you to solve the same problem, right? The two horses, they are pulling the bunch, and this time they are at different angle. The force exerted by the two horses are still the same. They are 600 Newton, 600 Newton, still the same. Each horse can exert a force of 600 Newton. Only change is in the angle. The first horse, the angle is 40 instead of 30. The second horse, the angle is negative 20 instead of negative 45. Okay, right. So we again we refer to this one. This diagram here is exactly the same as this diagram here. Exactly the same. So the first force, we are going to resolve it into two components. The second force, we are also going to resolve it into two components. Okay, two components. Right. Then I sum up the horizontal components. So it's over here. It's over here. It's the same as this one. Same as what we have done just now. But you just replace it with a different number. Here 30, you replace it with 40. Here negative 45, you replace it with negative 20. So what we are doing here is the same as what we have done here over there, right? So you try to find the horizontal component of the resultant force. Next, we try to find the vertical component of the horizontal force. So you take the vertical component plus the vertical component, but this time replace the angle with 40 and negative 20. Okay, so after finding this, then you combine the two forces together. Right? So now can you try these two and see whether you know how to find the horizontal and vertical component? Use your calculator.
so are you sure it's 1020? Because I use both calculator, got 1023.
How much is that?
1023.
Oh, 1,000. They round off to three significant figure, I think. Because
Oh, okay, okay, okay.
if I use 23 here, then later on, at the last part here, maybe I will get a different angle from the answer they give me. I got a different answer. Because the book, they round off the number right from the first step. For each calculation, they round one time. Each calculation, they round off the number one time. Okay, right. You try the vertical component, can we get
I got,
180?
I got, yeah, I got 100.
Okay, then you combine these two together using Pythagoras theorem. Okay, so it's the square root of 1020 square plus 180 square.
Okay, yeah, I can see what it did. Yeah, yeah, I got the same thing. I got 1035 point something, but you
It's
rounded off
okay.
to 1.0.
Yeah, you round off, you will get this number, right? So this will be the acceleration, this will be the net force, right? Then you use Newton's second law, net force is equal to mass times acceleration. So this net force here, 104 here, you put inside the net force. The mass of the barge is 2000. Then you try to find whether you can get this number or not. Divide 1040 with 2000, see whether you can get the acceleration to be 0.520. You try and see whether can get the number or not. This is what I got, and it's the same as the answer given.
The 180 divided by 1021, right? So
1.0.1176, or you get, you want to round off, or you
yeah,
try not to round off.
I no, I didn't round.
Okay, then
0.176.
you type shift tangent, and can you get 10 or not? I got 9.98 only.
I got 9.98.
9.98 also. Okay. So this is how you find the resultant force, right? This type of question is said earlier on, the propeller one, this type. We find the net force because they are actually along the same line, along the same line. The the propulsion and the resistance, they are along the same line. But in the second example here, the horse, the two horses, they are along different lines. They are acting at different angle. So if they are at different angle, this is the method to find the resultant force. If they are along the same line, very easy. You just subtract them. Where is it? Over. You just subtract them. The net forces. You just subtract them, right? But here, if you want to find the resultant force, this is the method. Okay.